So in this video, I'm going to talk about a problem that I'm sure all of us have seen. Essentially looked at classifying a problem using any kind of deep network. So you started to do the classification. You took an algo that made sense. You put some parameters in, and then you looked at essentially the performance. And what you get is not what you want. And there's so many different things you can do. You can look at changing up and moving to a better model, probably more expensive model. You can look at changing your optimizer. You can look at essentially doing regularization. You can change the number of epochs that you train. All of that is possible. How do you even start to identify the root cause and look at how you're going to solve this, right? Deep learning models, right, by nature, because they don't give you any insight on what is happening, sometimes you essentially end up with a very blind situation. So what I do is essentially I look at where I am in terms of my accuracy. And if you really look at the overall space, right, generally speaking, you are looking at an F1 score of, let's say, 90 to 95 as a target, because that's the number at which you start to say, okay, I can take a human out of the loop and actually put this directly in front of customers. So if you are not getting an accuracy even up to like 60 or 50, there is no point in trying to optimize your model. You have data issues, and those data issues need to get sorted before you can do anything else. Data issue is probably the most common reason the models doesn't have very good accuracy, and it is useful to actually catch them early when you know that your accuracy is very low. Otherwise, catching them later when your accuracy becomes high becomes even harder. The biggest problem I see there is very few samples, inconsistent labeling, and skewed data. So having very few samples is an obvious one. Inconsistent label is again an obvious one. You can look at the labels, and if sometimes even the labeler is not very clear, if you just give them the same uh, images or data to label, they probably label it differently the next time. So that's inconsistent labels. And then finally, skewed data, right? This one is a bit tricky to understand. So I'll give you an example. So I was trying to classify a bunch of human images based on their intensity of wrinkles, and we essentially classified wrinkles into various categories and grades. Now the images that we got, right, they had this huge skew that most images were for slightly older people. Now what that means is the models in some way were learning that age is basically a primary factor for classes that had high grade uh, wrinkles. Now that is what I call skewed data. And you need to make sure that your data is not skewed and it is uniform in some way, so that other than the basic property that you want to learn, for all other dimensions, the data should actually be uniformly spread. This is something that takes time for you to really get a sense on, but I've seen this happen very often, because the way we collect data, and the data is collected by, let's say, interns and a lot of other people who are a little removed from the people who are doing the classification, they would essentially go and try to get the data as quickly as possible. And chances are, if you follow an approach like that, you will have skewed data. It's only once you have an accuracy beyond 50-60 that you should start look at model issues. That's where you say that, okay, maybe I need a more expensive model. For example, if you're doing image classification, you started with MobileNet, then you're going to evaluate RestNet, and then you're going to also evaluate EfficientNet and see what kind of a latency can your systems tolerate, what kind of cost can you spend, and then see where you're essentially going to find the right fit. And then you're essentially also going to look at parameter tuning. We're going to look at your optimizer. Maybe you say Adam is not good enough. I want to look at SGD. But once I look at SGD, I have to make sure I can actually use the right parameters for SGD. It's essentially tricky. You look at whether you have overfitting. You look at essentially things like whether your uh, training accuracy versus your validation or test accuracy is very different. Then you look at regularization or drop off. And those are the things you start to look at. But you don't look at them if your accuracy is already below 60. Very often, what you will also find is that you've done everything. You've looked at all your data, you've pushed all the teams to get as much data as you can, you've looked at the labels, get them right, ensure there's no skew, and then you essentially looked at the models, tuned everything, and then you're stuck at, let's say, 70 or 75 iPhone score, and the project dies because unless you get to, let's say, 90, you cannot go live in front of the customers. So what do you do? At places like those is where I think you need to be really smart. And when I'm saying smart, here it's essentially about being street smart and really get into the domain and understand, are there other proxies that you can use that can give you an extra dimension that you can use for your classification? Sometimes what you can do is you can look at multiple models. For example, I mean, we were training essentially, again, people and trying to get their grades of acne. We essentially use one model, which is essentially based on acne counting, and another model, which is essentially just based on classification. And combining those two models actually got us a score that was good enough to take live, whereas individual models were not good enough. The other thing that you should look at is basically look at raw scores. So if you're doing a classification, and let's say class A has an accuracy, has a confidence score of 35%, and class B has 33%. And if you use softmax as the last layer, which you invariably will use, you will essentially say class A, even though class A and class B, actually there's nothing to separate them. So in those scenarios, you have to look at other attributes in your domain and see, can I use them to give an extra boost to my accuracy? And those are what will actually take you from being an average model that you essentially are not comfortable if it is good enough to go in production, versus a model that everyone is confident and is happy with, and the customers are happy because it's fairly accurate. So in scenarios where, let's say, you have a categorical classification, you have two classes, you should definitely look at other attributes. For example, right? I mean, in the case of acne, or even in the case of wrinkles, right? Age is a good proxy. Age is a good attribute for you to say, if can I use age to say people who are very young cannot have very high grade acne. Those are the kind of extra information you can have. And those you don't use all the time. For example, if a particular class is getting a score of zero point 0.9, the other class is getting a score of 0.05, you're not going to use those. But when things get close from the model perspective, that's where the model is making errors. And that is where you can actually add additional information from your domain and get to that 90-95% kind of F1 score, where you can actually go and deploy this in production. So that's essentially basic thing, that if you have a problem that's stuck in the 50s and the 60s, then you have data issues. That's what you have to go fix first. It's only once you've gone beyond those that you should look at model issues and look at finding better models and optimization parameters. And then even then you will get stuck. Chances are almost everywhere you will get stuck. And unless you apply ideas from the domain to really, really help in those cases where the model is not giving you very, very clear signals, that you can get to an accuracy of 90-95, where you can deploy it in production without a human in the loop and directly expose it to your customers.